because really all of this is stuff that you've seen before, mainly in probably Algebra 1, probably not really in geometry, but definitely in Algebra 1 with the different properties of exponents. Okay, Chapter 5 is going to deal with exponentials or exponents and radicals and stuff like that. We'll really get into it second semester, but there are some of these that are on the final, so it's just really just to make sure that you remember what you're supposed to be doing and what you have. Okay, so of any of these, you've got 4 different types of problems, and you have 3 really simple questions. Okay, so which is the coefficient, which is the base, and then which is the exponents? Okay, it probably should be named properties of powers because the power is the whole thing. Okay, so whenever we talk about this, if we're going to deal with I'm just going to kind of color code this as far as which is the coefficient. So the ones that are going to be the coefficients are going to be the ones that are in red. Okay, or I'm just going to highlight them in red, things like that. So as far as 4x to the 5th, which one is the coefficient? Okay, which number is out in front of our exponent or of our power? So like a 4x to the 5th, which one of those applies? Okay, you have a 4, you have an x, and you have a 5. Which one is the coefficient? The 4? Okay. What then would be the base of my power? What is getting multiplied by itself multiple times? The x. So the x would be the base. And then lastly, which one is the exponent then? The 5. Okay. So the coefficient is just if we're multiplying something, if it has a number out in front of whatever is being taken to a power. Okay. Now, I'm just going to slide down to where it's 93 times x plus 4 to the negative 5th power. So what does the 93 represent? Does it represent a coefficient, a base, or the exponent? The coefficient. Okay. So the 93 is the coefficient. What does the x plus 4 represent? It's the base. The whole thing is the base. And then lastly, the negative 5 would be my exponent. So if we went here, now let's go here. What about for 2/3 to the 1/2 power? What are we missing? Coefficient. Okay, we don't have a coefficient. Your coefficient in this case is 1. If it's 1, we don't write 1. We don't write 1 times and then everything else. So whenever we go from here, so the next thing that we're going to deal with is going to be the base, which is the whole thing. Okay, because it's in a property, or it's in a parenthesis, and then the 1/2 would be my exponent. Last one. I have 4 to the negative 5th, and it's all divided by 1/3. Now, this one's a little tricky. First off, let's go a little bit backwards because, first off, is there a coefficient? See head shaking no. I hear somebody say yes. Okay. Is there a base? Yeah, what is it? Is it the 4/3 or is it the 4?
It's the 4.
Okay, why is it the 4?
Because it's being multiplied by the exponent.
Right. Why isn't it the whole thing? Because there's not, very good, there's not a parenthesis. Okay? If there was a parenthesis around it, then it would just be like the 2/3 to the 1/2 power. Okay, there's no parentheses, so the only thing that is the base is going to be your 4. So then the easy part, hopefully, is that the 5 is, or the negative 5, is the exponent. So then what is my actual coefficient? You're close. What if I rewrote this as 1/3 times 4 to the negative 5th power? Dividing by 3 is the same thing as doing what? Multiplying by 1/3. Okay? So if you have anything divided by a value, it's different than the one right before it where it was the 2/3 because the whole thing was inside the parenthesis. Everything was taken to the 1/2 power, the 2 and the 3 together. Whereas here, just the 4 was taken to the negative 5th power. Okay? And then we were left with that dividing by 3, which is the same thing. So in terms of what is my coefficient? Well, 1/3 is my coefficient. Okay? Not just the 3, but the 1/3 because I can rewrite the dividing as multiplication. So then a lot of these, again, this is something that is not new. Where whenever you multiply like bases, okay, then you just add the exponents. So if you have the same base, they get multiplied together. I'm going to take my exponents, I'm going to add them together. Okay. If you have a power of a power, now I don't like that we use the x. I would rather, if we're going to do this up here, it would just be like m times n. Okay, so instead of, if you want to write it as m times n, I would do that instead of m and then the x and there. So if you have what's called a power of a power, I'm just going to take the powers and I'm going to distribute it or multiply it with every power that's inside. Same way, if I have AB and all of it's to the nth power, then the n's going to go here and there, so it goes to every single part inside the parenthesis. It's just like distributing. Okay, if you have multiple terms inside a parenthesis, then that power is going to go to everything inside there. Same way, or just kind of really the opposite. If we multiply, then we add our exponents, whereas if we divide, then we're going to subtract. Whatever's on top gets subtracted by whatever's on the bottom. Okay, and then vice versa, where these two are very similar. If you're multiplying and everything's inside the parenthesis, then that power goes to everything inside. Same way if you're dividing. That power goes to whatever's on top and whatever's on bottom. So it's really no different. Again, you've seen this before, you've done this before. It's nothing new, or it shouldn't be. If it is, then your Algebra 1 teacher really short-sighted you in terms of the math department. A couple other properties of exponents. Anything taken to the 0 power is just 1. If you think about it like this, if I have, and the reason why it's 1 and not 0, and the most common mistake is students want to put 0, is because if I have a to the 4th over a to the 4th, a lot of students want to go, well, it's 0, there's nothing left. No, it doesn't work that way. Okay, remember if I had a times a times a times a, and I did the same thing on the bottom, what would happen to everything? It would cancel, right? Whenever I'm dividing and everything cancels, it's just left with 1. It's the same way if I had 25 divided by 25. Is 25 divided by 25 0? No, not today. It's just 1. It's the same idea. Okay? But yet students think, oh, everything cancels, it's going to be 0. No, it doesn't work that way. Don't get in too big of a dang hurry and pay attention to what you're doing and go from there. Negative exponents, like it says, they're okay. They just need to be simplified. If you have a negative exponent, you just need to basically put it on the opposite side. So if it's on the top side of your fraction, put it on the bottom. If it's on the bottom side of your fraction, put it on the top. Okay, so you should never end with a negative exponent. You should always have a positive exponent, either in the denominator spot or in the numerator spot. Okay, your assignment is just at the bottom of this. You are, and it's on Canvas.